Hello, yes, and welcome to our Objective 1.6 notes. Now, Objective 1.6 says I can use function notation to identify the output of a function for a given input. And this is something you've actually already been doing a bit this unit, but this objective really is going to focus on solidifying these skills. So first, let's talk about function notation. Function notation is this f of x here. Now, f of x, so f is the name, so to speak, of the function. So you'll see different letters. You'll see g, you'll see h, and those are just identifying the different functions. Whatever is inside the parentheses is the input. All right. So that input is what we are plugging into the function f. So in equations, f of x really serves the same purpose as y. That is, x is still the input, and now f of x instead of y is the output. So we're going to evaluate a few of these functions and see how we do. So a says f of n is 3n plus 1, find f of 4. So to do that, all I need to do, anywhere there's a 4, or anywhere there's an n, I'm going to plug in 4. So I'll say f of 4 equals 3 times 4 plus 1. And then I'll just simplify this. So 3 times 4 is 12. 12 plus 1, so that means f of 4 is 13. And that would be my answer. Now notice, if my input is a number, my output, my f of 4, my simplified version, is also a number. So let's try b here. F of x equals the absolute value of negative 2x minus 3, all minus 2, find f of 8. So I'd say f of 8 equals, and anywhere there's an x, I'm going to replace it with 8 minus 2. So this will be the absolute value of negative 16 minus 3, and then minus 2. So negative 16 minus 3 is negative 19 minus 2. Now, absolute value measures a number's distance from 0, and negative 19 is 19 units away from 0, and so that means the absolute value of negative 19 is 19. 19 minus 2 is 17, so that means that f of 8 equals 17, and that would be my answer for that one. Now, for both A and B, we were plugging in numbers as our inputs. We can also plug in other equations or other expressions. So let's look at letter G here. G of x, or letter C here, sorry. G of x equals x squared minus 3. Find G of x minus 2. So anywhere that there was x, I'm now going to put x minus 2. So to simplify this, the first thing I'll need to do is x minus 2 squared. So that will equal x minus 2 times x minus 2. And then I'll subtract 3 from that. So that'll be x squared minus 4x plus 4. And then minus 3. 4 minus 3 is 1. So x squared minus 4x plus 1. And that is what g of x minus 2 equals. So notice, whereas with A and B we inputted numbers and we got out a number, for C we input an expression and our answer is also an expression, okay? That's an easy way to check to make sure we're doing things right. So g of x minus 2 equals x squared minus 4x plus 1. Let's try one more together. H of x equals 3 times the absolute value of x plus 7. Find f of 4x minus 1. All right, so, I think this is supposed to say h of 4x minus 1. Silly, silly. So h of 4x minus 1 equals 3 times the absolute value of 4x minus 1, and then plus 7. Okay, so some of the challenge here is knowing how far we need to simplify. So let's start by simplifying inside this absolute value. 4x minus 1 plus 7. Well, negative 1 plus 7 would become positive 6. And then you say, well, should I multiply this 3 in? How does this work? And the answer is no. Don't multiply that 3 in. This is actually as simplified as it can become. So h of 4x minus 1 will equal 3 times the absolute value of 4x plus 6. And that right there is our final answer. All right, hopefully we're feeling confident with Objective 1.6. We're feeling good about finding an output for a function with a given input. If you want to watch a few more examples, go ahead and check out that sample video. Otherwise, go ahead and get started on those practice problems. This is Mr. Carter signing off. I'll see you next time.